In 1968, the doctrine of mutually assured destruction defined the global landscape. Both the United States and the Soviet Union relied on ballistic missile submarines, sending them to hide in the deep ocean to hold adversary coastlines at constant risk. On February 24th, a Soviet Golf II-class submarine named K-129 departed for a patrol in the North Pacific, carrying 3 nuclear missiles and a suite of cryptographic codebooks. A few weeks later, it missed its marine operational check-ins. The Soviet Navy launched a massive, frantic search and rescue operation across thousands of square miles of empty ocean, but they had no idea where their submarine had gone down. The United States, however, was listening. Naval analysts checked telemetry from SOSUS, a classified network of underwater hydrophones anchored to the seabed. They isolated the exact acoustic signature of a catastrophic internal explosion and hull implosion, localizing the wreck to within 5 nautical miles. In July, the U.S. Navy dispatched the highly modified USS Halibut to search the coordinates. Using early remote-operated camera arrays, the Halibut found K-129 resting upright in the abyssal mud at 16,500 feet, nearly a mile deeper than the wreck of the Titanic. The photographs revealed a significant intelligence opportunity. The submarine had broken apart, but the sail structure, housing the cryptographic encoding machines, was accessible. Nearby, at least one of the nuclear ballistic missiles remained intact inside its launch tube. The National Security Council wanted the entire submarine, but the recovery site sat in international waters. Any overt deployment of U.S. Navy salvage ships would immediately flag the exact location to passing Soviet patrols, who would likely scuttle the site with deep-sea explosives. The military lacked a plausible reason to build a specialized salvage ship and park it over a single patch of ocean for weeks. The Department of Defense handed the problem to the Central Intelligence Agency. The CIA needed a civilian frontman. They selected Howard Hughes, the eccentric industrial billionaire who already possessed the vast corporate infrastructure needed to hide a covert operation. Through his privately held Summa Corporation, Hughes announced a massive investment in an entirely new industry, deep-sea mining. The company claimed it was going to harvest manganese nodules, potato-sized mineral deposits rich in nickel and copper, directly from the abyssal plains. This narrative justified everything the CIA needed. It provided a legal explanation for the ship's massive, unconventional heavy lifting gear, and it gave them an excuse to hover over one specific set of coordinates in the Pacific Ocean for an extended duration. Because Hughes Corporation was entirely private, there were no public shareholders and no regulatory reporting requirements. The CIA quietly funneled hundreds of millions of dollars through his accounts to build a specialized maritime espionage platform in plain sight. The result was the Hughes Glomar Explorer, a 50,000-ton, 618-foot-long vessel engineered specifically to retrieve K-129. To maintain secrecy, the ship abandoned conventional external cranes. Instead, engineers designed the moon pool, a cavernous, flooded compartment located dead center inside the ship. 2 hydraulically actuated gates on the bottom of the hull could open, allowing the crew to hoist the Soviet submarine directly into the belly of the ship, shielding it entirely from passing vessels and overhead satellites. Lifting a 2,000-ton load requires a rigid 3-mile steel pipe string. If ocean swells caused the surface ship to pitch and roll, that movement would send immense dynamic shock waves down the pipe, fracturing the ultra-high-strength steel instantly. To solve this, engineers built a 630-ton gimbaled work platform supported by pneumatic hydraulic rams. Acting like a massive stabilizer, it absorbed the ocean's movement, allowing the ship to roll with the waves while the central lift mechanism remained perfectly vertical. At the very bottom of that pipe string sat the capture vehicle, nicknamed Clementine. This 2,000-ton steel claw was designed using the Halibut's photographs to perfectly match the contours of K-129, sliding its articulated fingers underneath the rusted hull. The mission forced humanity to master extreme deep ocean dynamics, establishing the first practical methods for precise station-keeping and heavy sea lifting. On July 4, 1974, the Glomar Explorer arrived over the wreck site. Almost immediately, a Soviet naval missile range ship arrived on the scene. Under the direct, watchful eyes of Soviet helicopters and naval officers, the CIA crew had to execute the lift while pretending to run geological mining tests. Operating entirely within the enclosed derrick structure, the crew began the tedious process of assembling the heavy lift pipe string. Section by section, they lowered Clementine thousands of feet into the darkness at a rate of just a few feet per minute. The claw successfully gripped the submarine, and the long ascent began. But on August 4th, at a depth of 9,000 feet, the uneven load of the corroded hull overwhelmed the brittle maraging steel fingers of the claw. Multiple arms violently snapped. Deprived of support on one side, K-129 split apart. 2/3 of the submarine, the segment holding the cryptographic codebooks and the intact nuclear ballistic missiles, broke free and plummeted back to the seafloor. After years of planning and hundreds of millions of dollars spent engineering a mechanical marvel, a single metallurgical failure in the water column cost the operation its primary intelligence targets. The crew did manage to hoist the remaining 38-foot forward bow section into the moon pool. Inside, weapons technicians recovered 2 intact nuclear-tipped torpedoes, providing precise data on Soviet warhead triggers. They also discovered the remains of 6 Soviet submariners, who were given full military honors and a formal burial at sea. The CIA immediately drafted plans for a second mission to retrieve the fallen missile bay, but back in Los Angeles, burglars broke into the offices of the Summa Corporation, stealing highly confidential documents that explicitly linked Howard Hughes to the Central Intelligence Agency. The burglars attempted to blackmail the agency. When the CIA refused to pay, the documents leaked. In March 1975, investigative journalists, led by Jack Anderson and Seymour Hersh, published nationwide exposés detailing the true nature of the Glomar Explorer. Humiliated, the Soviet Union stationed a permanent naval vessel over the wreck site, ending any chance of a return mission. The exposure triggered a legal crisis. Journalists weaponized the Freedom of Information Act, demanding the CIA hand over all records regarding the Salvage project. If the agency admitted the files existed, FOIA law would compel their release. If they claimed no records existed, they would be committing perjury. To survive the dilemma, a CIA attorney crafted a highly specific, intentionally ambiguous legal response. We can neither confirm nor deny the existence of the information requested. While the CIA missed the cryptographic codebooks, the legacy of Project Azorian remains visible in every deepwater vessel today. Once the classified project concluded, these engineering breakthroughs transitioned into the commercial sector, where the designs for automated station keeping and heavy lift pipe strings formed the foundational technology for modern offshore oil exploration and subsea cable laying. Project Azorian stands as a rare moment where a failed Cold War heist built the infrastructure of the global maritime economy.